Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, finding the nature of your roots. Now, if you're new to my channel, I put in timecodes in for this video in the description box below, so use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 4 parts. Leave a like, smash subscribe, and let's get started. In my previous video, we talked about complex roots. So now we should know that our polynomials can have either real roots or complex roots. If you hadn't seen that video, no worries, you can check it out right up here. However, there are some times where we're a little bit less interested in finding the specific roots, but we're more interested in understanding the nature of our roots. Now, what do I mean by nature of our roots? Well, that's simply asking, is the root a real number or is it a complex number? And if we're talking specifically about quadratics, we know that our quadratic should have 2 roots. But there are also some situations in which we're a little bit less interested in finding the specific roots, but we're more interested in understanding, are the roots distinct? Are they the same root or are they 2 different roots? Today we're going to be asking the question, can we find out the nature of our roots and if they're 2 distinct roots without actually solving for our roots? And the answer is going to be yes. We can do both of those using something called the discriminant. Now, the discriminant is just going to be the following. The formula for your discriminant is going to be b squared minus 4ac. Now, this should look fairly familiar because this comes directly from your quadratic formula. If you were to complete it, let's say, do this, this is your quadratic formula. But we're not interested in all of this. We just want this piece here, and this is called the discriminant. Now, of course, since the discriminant is going to come directly from our quadratic formula, we should already know how to find our a, b, and c for this. This is going to tie directly into your standard form, your a x squared plus bx plus c for your formula. This is going to fall right in line with what we're used to doing. So you're going to take your a, take your b, and take your c and plug it into this and see what we get. And the outcome of this is going to fall into one of 3 categories. You have where it's less than 0, you have when it's equal to 0, and you have when it's greater than 0. So after plugging a, b, and c into your discriminant and you find that the result is less than 0, we know that this means your roots are going to be complex. If the result is equal to 0, you have real roots. And if your result is greater than 0, you have real roots. So that's how we can use our discriminant to figure out the nature of our roots. But how about if our roots are distinct? Well, it's going to help us do the same thing. If we go back to where the result is less than 0, this tells us that we have 2 distinct roots. If the result is equal to 0, we have 1 distinct root. And if it's greater than 0, we once again have 2 distinct roots. So if the result is less than 0 or greater than 0, we know that we're going to have 2 different roots. They're not going to be equal to each other. But if it is equal to 0, it's going to be the same root that's repeated. So since we have 2 roots, we have 2 roots that are going to be equal. And if we put everything together, when our result is less than 0, we're going to have 2 different or distinct complex roots. If it's equal to 0, we're going to have 1 root, but it's going to be a real root that's repeated. And if it's greater than 0, we're going to have 2 distinct real roots. So let's use our discriminant to find the nature of our roots for our next few examples. So for our first example, we have 2s squared plus 9 equals 0. And we want to use our discriminant to find the nature of these roots. Are they going to be complex? Are they going to be real? Are they going to be distinct, or are they going to be the same? So the first thing we want to do is identify our a, b, and our c. But notice this doesn't have an s here. We have an s squared and we have our 9. There is no s. So technically, our B is going to be 0. Our A is going to be 2, and our C is going to be 9. So we're going to plug all of that in and see what we get. So we have B squared, which is going to be a 0 squared, minus 4 times A, which is 2, times C, which is 9. And we automatically see what we're going to have here. This is going to be all the way negative. We don't even have to do this math. We know this is going to be less than 0. You have 0 minus 4 times positive numbers. This is going to be negative. And once again, we're not trying to find the roots. We're just trying to find the nature of our roots. So this is all we need. Now, what does a negative discriminant mean? Well, if we have a discriminant that is less than 0, we know that we're going to have two distinct complex roots. Less than 0, they're going to be complex and they're going to be different from each other. So let's move on to our next example. In our second example, we have k squared plus 4k plus 4 equals 0. Now let's first identify our a, b, and c and move into plugging them into our discriminant. So our a is going to be 1. We have a b this time. It's going to be 4, and our c is going to be 4 as well. So plugging all that in means we're going to have a 4 squared minus 4 times a, 1 times c, which is another 4. And you can kind of see what's happening here. 4 squared minus 4 times 1 times 4, which is pretty much 4 squared. This is going to all cancel out and give us 0. Now, what does the result being 0 mean for the nature of our roots? Well, if it's 0, we're only going to have one real root. One real root. Now, you have two, obviously. This is a quadratic, but it's not distinct. So this is one real root, or a double root, or even a repeated root. So you can say this is one real repeated root. Let's move on to our last example for today. In our last example for today, we have 5g squared plus 2g minus 3 equals 0. So let's identify our a, b, and c and then plug them in. So a is going to be 5, we have b equaling 2, and we have c equaling a negative 3. Plugging that in, we're going to have b squared, which is 2 squared, minus 4a times 5c times a negative 3. Now we know that our negatives will cancel out with each other. So technically, you're going to have this 4 plus 4 times 5 times 3. Notice there are no more negatives here. So this is going to be strictly positive. There's no negatives. This is definitely not canceling to 0. So we know that this is going to be strictly positive. We don't have to actually finish this math here. What does the result being greater than 0 mean for the nature of our roots? Well, we're going to have two distinct real roots. When the result is greater than 0, you have two roots that are real and they're different from each other. So I hope you were able to follow along with today's video, and I hope you now know how you can use a discriminant to find the nature of your roots. However, if you have any questions about what you saw today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to hit that like. It surely helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping to help with your homework. I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.